Now let's actually look at using relay domains with maps. Now, database maps provide a way for postfix and other MTAs such as QMail as well as SendMail the ability to query in a lightning fast fashion, if I may, large amounts of data's mappings, relationships, table structures. Rather than actually querying this information from a static list or a file which gets stored in memory and is static until postfix is reloaded, postfix supports a variety of database mechanisms, a plethora of database connection mechanisms such as Berkeley DB, btree, as well as LDAP, MySQL, and different repositories for accessing common information such as Access databases, mailer tables, and all of the common MTA table relationships that you'll find. What we want to do now is pretend as if our server is hosting many domains, and we'll also pretend that it's simply unreasonable or not practical to store the list of domains in the main.cf file. What we're able to do with postfix is to have many of its directives cross-reference a defined map, which means we can create a map, which is usually a two-dimensional file, a left side and a right-hand side, name value pairs or key value pairs, compile those key value pairs into a database format that postfix understands, and then make changes to those database files on the fly without even restarting postfix. Let's take a look at the current directive. We'll nano main.cf. Let's find relay underscore domains as it's currently defined with the newly included domain that we're going to handle relaying for. And there are many references to relay underscore domains. We'll just keep control Wing until we get to the one that we want. Here is the directive. This is the official relay underscore domains directive. So again, it may be impractical to list all the domains. Now we've only appended one extra domain. However, what if we had hundreds or thousands of domains as many ISPs do? Well, we can combine a combination of my destination or local variables within the main.cf file along with database type mappings. So we can leave my destination in place, which is already defined throughout the main.cf file, and as a separate entry make a reference to the database type that we are making reference to. Now, in order for database support to function within your Linux environment, you should have compiled postfix with DB support, which is generally compiled into postfix by default, providing that the Berkeley database software has been installed. You can confirm that by simply, if you're on an RPM-based system, simply executing RPM query all and grepping for the DB package. We'll use the -i option because it ignores the case. Here's the DB package, and in the db-devel package provides the necessary libraries for compiling against the Berkeley development libraries. So this is already in place. When we compiled postfix, it recognized the Berkeley development library and as a result provided support for that type of database. So we don't need to go any further. So as a result, we can make reference to any type of database supported by the Berkeley format, including hash as well as btree within a Linux environment. The most common mapping type that you'll find within a Linux environment is the hash type. So to make reference to your type or your type of mapping and the name, you simply execute or specify a format that looks like the following: type colon followed by the name of the file, including the entire path wherever possible. So type and file name. This is the format. This is the syntax. Generally within a Linux environment, the type is hash followed by the full path to the file. Now, it's a good idea to place your mappings within the etc directory, but within an ISP environment, for example, especially a busy ISP environment where you're likely to have thousands or maybe hundreds of thousands and potentially even millions of mappings, all sorts of relationships between various domains, you may want to store the database on a different partition that's faster, has more storage, and so on. So it's a good idea to always specify the absolute path from the root. But if you have small databases to manage, as in our case, then you can simply place those database files within the etc directory. Even if you set up Postfix for a company with a few hundred employees or even a few thousand employees, they're merely text files and they're very small. So you can feel free to maintain them in the etc Postfix directory. So the hash is the type, and the actual file, which we've yet to define, we'll call it etc, or specify that it resides in etc Postfix with the name of relay_domains. We can call it anything we want. Now the initial text file that we'll define will be called relay_domains, but when we use the postmap command to compile or to convert the two-dimensional text file into a binary database representation for speedy access by Postfix, it'll contain a suffix of .db. You don't need to explicitly specify that suffix because Postfix, like SendMail, expects that when you're using the Berkeley DB format that the file will have a suffix of .db. But that does not mean that you can get away with not producing the .db file. In other words, your Postfix implementation will break for key features such as relay_domains if you don't generate the DB file. So you must generate the .db file. So we're going to cross-reference a file called relay_domains. Now in our directory it doesn't exist, so we need to define this particular file. We'll nano relay_domains, and in it we'll place, now this file doesn't need to be two-dimensional, it doesn't need to have two columns, although most map files do. In this case, when you're defining additional relay domains, you can specify a single column, but the advantage to compiling these items into a database format is that you can make changes on the fly without restarting or reloading Postfix, and it's faster to access the information from any type of database versus from the file system directly. So we'll specify our domain linuxcbt.external, and for each domain that you intend to support or to relay mail for, in this case we're focusing on the relay feature, just enumerate them one line each, or give each domain one line. So linuxcbt.external is a domain. Let's add Linux computer base training.internal, and we'll also add Linux computer base training.external. So now we have 3 extra domains that we're handling messages for. Well, we're relaying these messages, or the domains destined to these, the messages destined to these domains, but we're not serving as a final destination for these domains, which means that you need to have the proper DNS infrastructure set up or some sort of mailer table to route the messages properly to the destination system. So we have these 3 domains, but DNS is only set up for one. Let's save changes, and in order to generate the map, you'll use the postmap command. Now if you recall from when we compiled Postfix, we mentioned that Postfix produces binaries in 2 locations. One is user libexec. Those are the applications that run in the background and manages Postfix, and another is a directory is user sbin, where you'll find administrative commands. So if you execute which postmap, you'll see that it resides in user sbin because it's considered an administrative front-end utility for interfacing to Postfix, whereas the utilities that you'll find in user libexec Postfix are for the back end, for the daemons that run in the back end and actually manage the MTA. So a postmap executed against the file that you'd like to have mapped to the Berkeley DB format will generate that file. So we'll execute postmap against the relay_domains file, and this will generate the expected file. Now as you can see, it returns warnings because it expects keys and values. In our case, the file doesn't actually contain values. The value is the left-hand side, or the key. So this is a rare case where postfix will actually read the left-hand side, relay underscore domains, because as I've mentioned, generally mappings are two-dimensional. Left, right, left-hand side, right-hand side. In this case, postfix will actually read the keys and treat them as the values. So it'll read linuxcbt.external and the two other domains as the values. But postmap's utility, or the postmap utility, responds with missing or white space for values because it's unexpected. Generally, non-white space characters are expected for the values, the right-hand side values for the left-hand side keys. So now we have this database in place, but postfix doesn't know about it. So we should execute a postfix reload, or we can start or stop then start, which is essentially a restart of the postfix mail system. You can always examine varlog mail or wherever your system reroutes messages, and we've reloaded the configuration. And it says it expected X values, but it got Y. Well, this is when we ran postmap. Postmap logs using the logging facility mail as well. So notice the time difference, 1831 versus 1832. So postmap logged to the same file. So now that we have this in place, we should be able to relay, and you should be able to add on the fly additional domains and be able to handle messages for those domains. Great. Now we can test this out from the local system by attempting to send a message to a user at linuxcbt.external as we've done. Let's launch mutt, new message to root at linuxcbt.external, and we'll simply say testing mail using db. We'll save changes here. And we'll send the message. Now notice no bounces, and we should now re-examine the log file to see whether or not postfix understands that it is to route linuxcbt.external. And it knows it's to route it. It looked up the proper hosts, .72. So on the remote side, on linuxcbt work 1, there's the new message, testing using BD. However, if we attempted to send a message to one of the newly defined domains, and let's try it, we'll send to root at linuxcomputerbasedtraining.com, or in this case .internal, that is, not com. That'll go to the outside. Testing, relaying, using DB to domain without DNS or mailer table support. This will actually attempt to send the message, but it'll eventually bounce because postfix will not be able to resolve the mail exchanger for that for that particular domain. Let's examine the log file, and here you'll see the entries: host or domain not found. So it was unable to look up the domain linuxcomputerbasedtraining.internal, which leads us into our next section. Now that you know relaying is happening, it's being permitted, although again we are testing from the local system, but you can easily test this from a remote system and you'll see the same thing. Postfix will permit relaying, whereas if you attempted to relay using a domain that's not defined using the relay underscore domains directive, it'll fail. So what this sets us up for is a way to bypass DNS, because in some situations you may not want to have DNS set up for every single domain. Let's say you're a company with 10 domains, but you really only service one or two of them. Perhaps you'd like to set up DNS for one or two of them and simply relay messages for the additional domains based on mailer tables. So you may not want to maintain internal DNS for those additional domains, but you may have an outside requirement that DNS be maintained for those domains. So the messages end up at your postfix doorstep into the queue, and postfix needs to know what to do with it. So in the next section, what we'll do is set up a sendmail-like mailer table where sendmail accepts a message, and rather than performing a DNS lookup, it simply consults its mailer table, which will then tell it what to do with a message, which in other words will just force the message to go to a given host and let the given host figure out what to do with the message. So that's up next.